If you take a look on today's assignment, there are some examples. There's an example here that we're going to start with. Then on the back, there are several more examples. And then here are some easy problems to do that I'll help get you started on. But first, let's look at the examples. So example 1. I hope that you can see this from where you're sitting. That's why we're looking at it on the big screen. So the way that this strategy works is, first, look at what we've got. What I wrote were the chemical formulas for substances that are in the reactants. The reactants are on this side. And then there's an arrow that points to the products. The products are the things that you make. In this reaction equation, this is calcium hydroxide and carbonate oxide, and these react to make calcium carbonate and water. Calcium carbonate is like limestone. Carbon dioxide, gas, fizz. Calcium hydroxide, stuff that you put on your head when you relax your hair or get a perm. Now what I've done over here on the side was I listed the elements that are in those compounds. So you can find calcium somewhere in here, you can find oxygen somewhere, hydrogen, and you can find carbon. So all of these elements down the side are the elements that are up here in the chemical reaction equation. And then under each compound, I made some lines. And on those lines, what we're going to do is we're going to keep track of how many atoms there are of each element in that compound. So let me show you how to start this out. I'm going to start by counting the atoms of each element in the first compound. So you can write this down along with me. When I look at this formula, I see 1 calcium, and I see 2 oxygens, because the subscript out here multiplies in, and I see 2 hydrogens. Okay, I don't see any carbons here, so I'm not going to put anything on the carbon line. For the next compound, and you can keep writing this along with me, in carbonate oxide, I don't see any calcium, so I'm not putting anything on this line. I do see 2 oxygens. Okay, I don't see any hydrogens and I don't see any carbons, so I'm not going to write anything there. Then, the next compound, calcium carbonate, I see 1 calcium here, so I'll put a calcium on this line. And oxygen, I see 3. And hydrogen, I see none. And carbon, I see 1. So I'm going to keep track of carbon right there. Hey, wait a minute, I forgot this carbon over here. Look at that. There's a carbon there. Whoops. Can't lose my atoms. Okay, and then the last one, water. No calcium, oxygen, 1, hydrogen, 2, carbon, none. All right, so what I've done was I just started by listing all the elements, counting how many atoms of each element there are in the compounds that make up the reactants on this side and the products on that side. Sometimes to keep it straight, what I do is I make a little line between the reactants and the products so I can keep straight what I'm trying to balance, because I want to make sure to get the same number of atoms of each element on both sides. I want to have the same number of atoms on this side as I have on this side, because that will fulfill the conservation of matter law that says everything I start with, I have to end with. Now, let's take a look at what we've got. I'm going to circle all the atoms of each element on both sides and see how they match up. Calcium, I have 1 calcium in the reactants, I have 1 in the products. So that matches up. In oxygen here, I've got a total of 4 in the reactants. And over here, I have a total of 4 in the products. Here, I've got 2 hydrogens in the reactants, and over here, I've got 2 hydrogens in the products. Carbon, I've got 1 atom in the reactants, and I've got 1 in, hey, look at that. All the atoms on this side are the same atoms on this side. They all have the same number of each element. They don't have to be the same number of atoms in each compound, like this one has 2 and that one has 2, but this one has 3 and that one has 1, as long as it adds up to the same amount on both sides. So all the atoms that I started with in the reactants got rearranged to make these products. The same number of atoms are on both sides because conservation of matter law says everything you start with you have to end with. Everything just gets rearranged. How about that? Now these spaces up here, I didn't put anything in. When there's no number up here, that means that we just need one of each of those compounds to fulfill a balanced reaction equation. So I have one calcium hydroxide, one carbon dioxide, makes one calcium carbonate and one water. Those are the ratios of the substances involved in this chemical reaction. Now let's show what it looks like when you put numbers up there. Next example, number 2, on the back. Go ahead and flip over onto the back. Get a little closer to this one for you. Now, I've got some coefficients here. I've got a 4 in front of the aluminum, and I've got a 3 in front of this oxygen, and I've got a 2 in front of this is aluminum oxide. It's kind of a white powdery stuff that you see on aluminum things when they, well, it's the way that they rust, they oxidize. Sometimes you see it like on your screen door or something like that. So first what we're going to do is we're going to ignore these numbers. Let me just ignore those coefficients. If I ignore that coefficient for aluminum and I count on the line for aluminum how many there are, right here there's just one. Go ahead and write down 1. How many oxygens are there in that formula? None. So I'm putting down nothing for oxygen. I'm going to cover up this coefficient for the oxygen. And how many aluminums are there in there? There are none. How many oxygens are there? Subscript of 2, so there's 2. I'm going to draw a line to separate the reactants from the products. Okay, now I'm going to cover up this 2 here and count how many aluminums there are and how many oxygens there are in this formula. I see 2 aluminums, 3 oxygens. All right, so without these coefficients here, this is how many atoms there would be of each element on both sides of the equation. And it doesn't balance. 1 aluminum turns into 2. Well, where'd that other one come from? 2 oxygens turns into 3. Well, again, where did that other one come from? The reason for those coefficients up there, the reason for the 4, is to multiply everything that's in this formula. I'm going to multiply everything here by 4. 4 times 1 is 4. I'm going to multiply this by 3. 3 times 2 is 6. Everything that's in the formula gets multiplied by the coefficient. So these 2 aluminums get multiplied by 2 to make 4. These 3 oxygens get multiplied by 2 to make 6. Now look at how many we have on both sides. 4 aluminums on both sides, 6 oxygens on both sides. What we're trying to do when we balance a chemical reaction equation is figure out what should these numbers be. What should be the coefficients? We don't change anything but coefficients. The purpose is to get the same number of atoms of each element on both sides of the equation because of the conservation of matter that says that everything you start with, you have to end with. Ooh, that got a little bit close. Let's look at one of these problems from the very beginning. Take a look with me at number 3. Back off a little bit there. Okay. Number 3. What we're going to do first is fill in the blanks for each of these substances. Down the left side of the margin, I wrote the element symbols for everything that's in these substances. So for the first one, iron, Fe, I see 1 in the formula. And then the next reactant, I see hydrogen 2, I see sulfur 1, I see oxygen 4. These are the 2 reactants, things that we start with. And then I'll draw a line between the reactants and the products. Here in this formula I see 2 irons, I see 3 sulfurs, and I see 12 oxygens. And then the last substance I see 2 hydrogens. So all I'm doing right now is just going step by step through each substance. How many atoms of each element do I see before I try to balance this thing? Now I see that on the reactant side I've got fewer atoms of everything. Fewer irons, well, I got the same number of hydrogens. Fewer sulfurs, fewer oxygens. So where did all these extra atoms come from? It must be because there's more pieces of the substances than I'm showing here. To get started, sometimes what you got to do is just look for something easy that you can fix. So for example, over here I've got 2 atoms of iron. And over here, I've only got 1. That doesn't balance. I need to get more. Over here, I've got 3 atoms of sulfur. Over here, I've only got 1. So I need to get those to match up somehow. Well, what I can do here for the iron is I can multiply this formula by 2. If I multiply that by 2, that means that I've got 2 irons. All right, well, what about the other atoms? If I've got 3 sulfurs on this side and 3 on this side, I want to have 3 over here, so I'm going to multiply this formula by 3. Now when I do that, it multiplies everything in the formula by 3. So the hydrogens get multiplied by 3. Now I've got 6. The sulfurs get multiplied by 3. Now I've got 3. And the oxygens get multiplied by 3. Now I've got 12. See how the 3 times 2, 3 times 1, 3 times 4. I'm just keeping track of what I'm doing down here so I can see how it all comes out. All right, so far so good. I've got 2 irons on both sides. I've got 3 sulfurs on both sides. I've got 12 oxygens on both sides, but what about this? I don't have that balanced yet. So what could I put up here to get this 2 to balance that 6? I can't hear you. Right, okay, good job. I'll put a 3 up here. If I multiply 2 times 3, then I get 6. Now I've got 6 atoms of hydrogen on both sides and it's balanced. I have the same number of atoms of each element on both sides of the equation, and that balances the equation so that it satisfies the rule of conservation of mass and matter. So what we're trying to do is get these numbers up here. What number goes right here? That's right, there's just a 1. You don't see it there. We have just 1 of this compound to make that formula. 2 atoms of iron, 3 molecules of sulfuric acid makes 1 iron sulfate and 3 little bubbles of hydrogen gas. Okay, so we're balancing chemical reaction equations by changing coefficients, the numbers that go in the front of chemical formulas. Let's try this next example. Start always by listing the elements that are in the formula and counting how many atoms of each element there are. You can write this down along with me. So here for sodium, there are 3. And for phosphorus, there is 1. And for oxygen, there are 4. There are no calciums and no chlorines in this formula, so I don't write anything here. The next reactant, there's 1 calcium and 2 chlorines. I don't have any sodiums, phosphorus, or oxygen here, so I don't have to write anything. Those are the 2 reactants. I'll divide my problem into the reactants and the products. Next substance, calcium. Okay, we got 3 of those. Phosphorus, there are 2 of those, because the 2 multiplies. 2 phosphorus. And oxygen, there are 8. And then the last one, sodium chloride, that's table salt. I've got 1 sodium and 1 chlorine. Sodium phosphate plus calcium chloride. This is kind of a rock salt that you can put on your sidewalk. It's more expensive. It's also used for preserving pickles. Makes calcium phosphate. You can find that in your bread. And sodium chloride, regular table salt. All right, so let's look and see what we've got. Does it balance? Sodium, 3 atoms over here. There's only 1, not balanced. 1 phosphorus, 2 phosphorus, and that's not balanced. 4 and 8, not balanced. 1 and 3, nope. 2 and 1, this thing's all out of whack. So what we've got to do is pick a starting point and get things fixed up. So this looks like an easy place right here. This phosphorus. What would I have to do to get 2 phosphorus on this side to match the 2 on this side? Did I hear you say put a 2 up here? Because if you did, then that's correct. If I put a 2 as a coefficient, then I'm going to double everything in the whole formula. Doubling the sodium to make 6, doubling the phosphorus to make 2, doubling the oxygen to to make 8. All right. Well, let's see. What else needs fixing? Okay. Oh, look at this 3 and that 1. Things that are easy to fix, like this, you can start with. So if I want to have 3 calciums on this side to match the 3 on that side, what should I put up here? Did I hear you say a 3? Because if you did, that's right, 3. If I put a 3 up there, it multiplies everything in that formula by 3. So now 3 times calcium and 3 times chlorine. Okay, so far so good. Except, well, let's see, I've got 2 phosphorus now, I've got 8 oxygens, but 6 sodiums, 6 chlorines. You can see what I'm going to have to do up there. I'm going to have to put a 6 here to multiply that formula by 6. Now I've got 6 sodiums, 6 chlorines. Let's check to see if it balances. 2 sodium, nope, 6 sodium, 6, 2, 2, 8, 8, 3, 3, 6, 6. It's all good. That's what we're trying to do. We're trying to get the same number of atoms of each element on both sides by changing the coefficients, the numbers that go in front. And what's the coefficient right there? It's a 1. We don't have to write 1s to show that there's 1. We just write the formula of the substance one time, and that means there's just 1 of that substance. I hope that you're keeping up with me here. This is exactly the same thing I'd be doing with you if I were in class, but I'd be able to stop and answer questions. If you have any questions, please raise your hand and keep it raised until I get back. I'll try another one. Number 5. You can put your hand down now because you're going to need it to write. Next one. Start with the elements. All these compounds have the elements that are listed on the side here. Start with the zinc. There's 1 zinc. There are no chromiums or chlorines here, so I don't have to write anything. The next one, I see 1 chromium and 3 chlorines, so I'll write those in. And then the next one, well, I'm going to draw a line between my reactants and products to keep track of where my balancing point is. And then chromium 1, chlorine 2, zinc 1, chlorine 2. All right. So here are my reactants and my products. Things look almost like they're balanced, but then chlorine here, I've got 3, and then here I have a total of 4. Now, this introduces a little bit of a trick. Sometimes you'll end up having an odd number of atoms on one side of the reaction equation, and on the other side you have an even number. Odd, even. How do you get that to balance? The way you do it is by taking the odd one and making it even by doubling it. If you multiply any odd number by 2, it becomes even, right? Of course it does. So, if you're stuck, you don't know where to begin because it doesn't look like you need to change anything except for this one right here, well, I'm going to just start by doubling this one and seeing how things shake out from there. So to make this 3 into an even number, I'm going to double this formula. Remember, multiplying this multiplies everything in the formula by that coefficient. So now my chromium becomes 2 and my chlorine becomes 6. Okay, now what do? Look what happened. When I made that into a 2, it stopped balancing. Now I've got to fix it. I've got to balance it. And this is going to help us get the problem started because now I know what to do. My next step should be to balance the chromiums. So up here, to make this 1 balance that 2, I'm going to multiply this formula by 2 because that'll multiply that 1 by 2. This 2 multiplies the whole formula. So now I've got 2 of those and 4 of those. Okay, now everything's balanced. Wait, let's look at this. Look at that. 1 zinc on both sides, 2 chromiums on both sides, chlorine, 6 in the reactants, and it's a total of 6 in the products. That's what we want to balance, the total number of atoms. So we don't have to have 6 atoms in one compound and none in another or some other. It has to be the total number that balances out for each element on both sides. So sometimes when you run into an odd number on one side and an even number on the other side, start by doubling it to get it going. All right, last example together. Example number 6. All right, start by listing the elements and counting them. For lithium here, we've got 1. And for water here, we've got 2 hydrogens and 1 oxygen. And then here's my balancing point. And then lithium, 1 oxygen, 1 hydrogen, 1 hydrogen here, 2. All right, balanced? No. 1 lithium on both sides, but 2 hydrogens on the reactant side, 3 on the product side. Oxygen looks balanced, but still, this isn't a done deal yet. This is an odd number trying to balance an even number over here. So the trick again, sometimes you have to make things all even. I'm going to do that by doubling this hydrogen to make it into an even number, because when you add up even numbers, you get an even number. I'm going to double this, and everything becomes doubled because I'm multiplying everything by 2. Now what? Well, this 2 and that 1 don't balance, so if I multiply that formula by 2, now I've got 2 on both sides. If these don't balance, then I can multiply this by 2, and that doubles everything. Now these balance. This 4 balances this 4. So now I've got the same number of lithiums on both sides, the same number of hydrogens on both sides, the same number of oxygens on both sides. What you're trying to do is get the same number of atoms of each element in the reactants and the products so that you have conservation of matter. Everything stays in the formulas. They just get rearranged to make new stuff. Hey, you know what? It's time now to try this on your own a little bit. We just worked on the examples. Now there are some easy problems. The reason I'm calling them easy problems is because I've already done part of the work for you. In some of these problems, like the first 2, take a look at those with me, you'll see that I've already provided you with some of the coefficients. And in some places I've already written in how many atoms there are for the elements. So you don't have to change anything that I've put there. Just work around the information that I gave you to get you started. Let me try one of these with you. Help you get yourself started. This first one, I'm just going to start by listing the elements and counting them. So here I've got nitrogen, there are 2 of them. Over here I already listed the hydrogens, and I put a coefficient of 3 here. That's why there's 6, because 3 times 2 makes 6. Over here the nitrogen, there's 1, and then hydrogen is 3. So now what you got to do is find out what's supposed to go in these coefficient spots. Well, this 2 doesn't balance that 1, so what am I going to put up there to make that 1 into a 2? Can I get a 2? I can get a 2. If I get a 2, that multiplies everything by 2, and check to see if it works. Those balance, and those balance. Here was my dividing line. The arrows separate the reactants from the products. 2 nitrogens on both sides, 6 hydrogens on both sides. So that's what you have to do. Work around the answer that I gave you so that you can get the rest of the problem. Like this one here. I've already given you the 4 irons that you need. I've already given you the 6 oxygens that you're going to need. So over here on this side, start with the 2 irons and the 3 oxygens that you're given in the formula and figure out what to do next. 4 irons on this side, 2 on this side, 6 oxygens, 3 on. So how do I get that to balance? How do I make 4 and 2 balance? If I multiply that by 2, then everything gets multiplied by 2. And now everything balances. 4 is on both sides, 6 is on both sides, it's even Steven. So continue to use that process as you work your way through the remaining problems. Hold on to your work until tomorrow. We'll take a look and see how you're doing. And I hope that you're finding some success with these problems. we're going to be using this technique throughout the remainder of this coming up marking period until the final exam. And I expect that I should be back tomorrow and we can continue working on this then. Have a fine day.